Part 21, Statistics. For the last 9 years, Mr. Finn has kept track of how many students get an A in his geometry class. He has found that there has been a mean of 6 A's a year, with a standard deviation of 1.8 A's. However, during the 10th year, there were 15 A's in Mr. Finn's class. That's a lot more than usual. Normally about 6 A's, now more than double. That's a lot of A's. Once the 10th year is included, how will the mean, median, and standard deviation be affected? Now, we don't know the exact numbers involved. We just know that the average number of A's for the first 9 years was around 6. And we know the standard deviation was, I think it said 1.8 or something like that, something small. So the number of A's stayed pretty close to 6. The only number we know exactly is that the 10th year was 15 A's. It'll make it more clear if we make a histogram or a frequency table of a hypothetical way that this might have looked. This histogram should give you an idea of what might have happened. Imagine that 1 year out of the first 9 we had 1 year we had 4 A's, another 2 years we had 5 A's, 3 years we had 6, 2 other years we had 7, and 1 year we had 8 A's, for an average of 6 A's. And also the way I've laid it out, the median would be 6 A's as well, right here in the middle. The question we're being asked is, if we add in that 10th year of 15 A's, how will this new information affect the mean, the median, and the standard deviation? Okay, that's the question. How will this change things? Now, look, first let's deal with the mean. These all represent numbers, so imagine that we just have this. Alright, now remember, I just made these numbers up in such a way to reflect the story, but we don't know the exact numbers. But this gives you a good idea. These numbers would have a mean of 6, like they said, and they also have a median of 6. And they're close together, which reflects the low standard deviation that we were given. Now, the question is, if all of a sudden now, if we add in this new data element of 15, I'm just going to stick this here on the end, is the mean still going to be 6 if I add this in, or is it going to increase, or is it going to decrease? Well, yeah, it's pretty obvious, because for the mean we just add them up and divide by how many we have. In this case we add them up and divide by 9, that would give us 6. If I'm adding in this unusually large number, this is going to turn out to be something higher than 6. It's going to increase. Okay, so the mean is definitely going to increase when I add in the 15. Now, what about the median? What about the median? Now, for this example that I made up, the median is 6. Okay, looking at just the first 9 years, the median is 6. Remember, the median is just the middle number if you put them all in a row like this. Now, the question is, if I add this 15 onto the end, is that going to increase the median the same way I increased the mean? Well, not necessarily. since the median is simply the middle number, no matter how big this number is I'm putting on the end, it's only one number. So let's see. Instead of 9 values, I have 10 values now. So this data could be separated evenly into two sets with 5 on the left and 5 values on the right. That means this is the middle right here between the 6 and the 6. In other words, I have two middle numbers. Whenever I have two middle numbers, if I want the median, I just add them up and divide by 2. Obviously, if I take the average of 6 and 6, I'm still going to get 6. So the median is still 6, even though I added 15 onto the end. So this is going to stay the same. The median is going to stay the same. Now, let's talk about the standard deviation. Do you guys remember what the standard deviation represents? The standard deviation represents how close together the data is, or how spread out it is. Another way of thinking of it is how consistent, how much it stays the same, or how much it changes. The closer the data is together, the lower the standard deviation is. The more spread out the data is, the higher the standard deviation. So more variation is a higher standard deviation. Less variation is a lower standard deviation. In this case, before we added in this extra 15, the first 9 years were very close together. Their average of 6, standard deviation was low. Less than 2, less than 2 A's of standard deviation. They were all close together. Adding in this extra value that's way over here to the right, that is making the data much more spread out than it was before. So we would expect the standard deviation to increase, because adding this 15 is spreading the data out. Everything was close to 6, 15 is far away, so now the data is much wider than it was before. So wider, more spread out data is a higher standard deviation. So just to review, we would expect the mean to increase when we add a bigger number on the end. We would expect that the median may very well stay the same. But the standard deviation would increase when you add an unusually high number. When you add an outlier, the standard deviation will increase because it's more spread out. So let's look back at the actual problem and circle some answers. Okay, so we expected the mean to increase. The median will probably stay the same. To be honest, we can't be 100% sure because we didn't have the exact numbers, but it has a good chance of staying the same. And we'd expect the standard deviation to increase under these circumstances. Well, Mr. Finn was curious about how many hours of sleep Roswell High School students get each night. He used his second period class as a sample and asked them how many hours of sleep they got last night. The results are shown on the graph to the right. What is the standard deviation of this sample? Now, do you guys remember how to calculate the standard deviation from a frequency table? This is how we do it. Remember, these bars represent stacks of numbers on a frequency table. So look at these numbers on the side. It just tells you how many there are. So this is a 1, because of the 1 down here. Looking at here, these people got 3 hours of sleep, but there were 2 of them, so this is like 2 3s. These are all 4s, 4 hours of sleep. 1 person, 2 person, 3 people. This column is people who got 5 hours of sleep. Okay, it represents 6 fives. These are all sixes. Okay, that's 5 sixes. These are sevens, 3 of them, and then there's an 8. So we can always translate a frequency table into a list of numbers that we could put in the calculator. So we want to calculate the standard deviation. So let's go ahead and type all these numbers into our calculator right now. Okay, it might be a good idea to reset the calculator. So if I hit second, 0, and put 2 for yes, now my calculator is reset. Everybody hit the data button. Now I can come here. Remember, this is where we can type in the data. Let's see. It seems like I'm going to have to switch back and forth a lot. Okay, we have a 1, 2 threes, and 3 fours. So here's a 1, 2 threes, and 3 fours. Okay, next I have 6 fives. So that's 1, 2, 3, 4, 5, 6. So I got 6 fives. Next I have 5 sixes. 1, 2, 3, 4, 5. Next I have 3 sevens and an 8. So 7, 7, 7, 8. Okay. Notice, for what it's worth, if I highlight this last number, it tells me how many there were. So there are 21 students in this class. Okay? Anyway, how do I calculate the standard deviation? See above the data button where it says Stat? I need to get to that menu. So I'm going to hit Second, Data, and I will find standard deviation under One Variable Statistics. So I can just hit Enter. All my information is in List 1, so I'm going to leave that highlighted. Hit Enter like 3 times. Now I get here. Now I have to be careful because there were 2 different numbers on this calculator that represent standard deviation. By the way, notice the N, that's the 21 students. X bar, that's the mean. That's the average amount of sleep they got. That's good to know. But anyway, as far as standard deviation, sometimes we use item 3, S, for standard deviation. Sometimes we use item 4, the sigma. How do I know whether I should be using the S standard deviation or the sigma standard deviation? They're very close, but how do I know which one to use? Well, maybe you remember that the S is for sample. We use this when we're treating the group that we're looking at as a sample. We will use the sigma, option 4, when we are treating the group as the entire population. Like, we don't care about data on anybody else. The group that we're looking at is the whole population. Now, look back at this problem so we can decide. Are we supposed to be using the population standard deviation or the sample standard deviation? We're on problem number 2. Ding, 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 ding. This word right here tells me that we need to be looking at the sample standard deviation. So when I look back at the calculator, I'm using the S. So be very careful about that. So the sample standard deviation, I'm going to say 1.62. I'll use the nearest hundredth. Okay, so watch out for use of the word sample. If they say sample standard deviation, you better use S. If they say population standard deviation, you will use the other one, the sigma. Okay. Now, look at number 3. Imagine that the student who only got 1 hour of sleep last night, that's this guy right here. Imagine that, let's see, last night he only got 1 hour of sleep. Now he gets 6 hours of sleep tonight. Assuming that all the other students sleep the same amount both nights, and again we're being asked, how will the mean, median, and standard deviation be affected? Well, let's look at this. Now, so we're saying we're taking this guy that was a 1, and he's not going to be a 1 anymore. He's now going to come over here and become a 6, because now he got 6 hours of sleep. Okay? So that's the change that's happening. Now, what do you think is going to happen with the mean? Well, if I took a low value of 1 and changed it into a higher value of 6, you can bet that the mean is going to increase. Okay, what about the median? Well, we have actual numbers here, so we can exactly calculate the median before and after the change. Okay, now as a matter of fact, look back at your calculator, because we just typed it in anyway. The median, the original median, is on this calculator screen. It's option number 9. The median was 5. Okay, so the median was 5 a moment ago. Okay, now by changing this value to a 6, now I actually could go back into my calculator and change the value to a 6, but I could just count these values. Remember, there are 21 students, so I could think of this group as having 10 students on the left, 10 students on the right, and the 11th student would be right in the middle. So the median is going to be the 11th student. So I can just count my way to the 11th student and see where it falls. So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th student is still going to be a 5, even though I move this over here. So the median was a 5 and it stayed a 5. So the median stays the same. Now again, I calculated the standard deviation the way it was, and we wrote it down over there. I could go back in the table, change this to a 6, and see what happens. But I already know what's going to happen. The data with a 1 over here off to the side, the data was more spread out. By taking this 1 and moving it closer to the middle, I'm making the data less spread out. So, when the data is more spread out, it has a higher standard deviation when it's wider. When the data is closer together, like I just made it, the standard deviation is going to get lower. So we would expect the standard deviation to decrease. Just for fun, you might go back and change the value to a 6, change the 1 to a 6 and see what happens. You want to do that? Yeah, let's do that just for fun. If I come to the table, change this 1 to a 6. There, I just changed the 1 to a 6. Now I could do my one variable statistics again really quickly. So let's look at the standard deviation. The sample standard deviation is now 1.3, 1.32. considering that it was 1.62, the standard deviation did decrease just like we thought it would. Let's look at that median. Just like we deduced, the median was 5 and the median stayed 5. So now I've showed you 2 different ways to solve that problem. Okay, let's move on to number 4. Alright, I'm going to need a little more space. Okay, number 4. There is a population of students who have a mean of 237 friends with a standard deviation of 28 friends. If you take 6 samples of this population, each with a sample size of 11, predict the standard deviation of the sample means. Is this ringing a bell? Especially this phrase right here. Standard deviation of the sample means. You guys, there was a formula that we had to know for problems that had to do with standard deviation of the sample means. And here's the formula. This formula is not going to be given to you, so I'm going to need you to memorize it and have it in your head for the EOCT. Here's what these represent. This is the population standard deviation. Population standard deviation. This one is also standard deviation, but this is the standard deviation of the sample means. Okay, and you can almost just read it. There's the standard deviation. Here's the symbol for sample means. So standard deviation of the sample means. That's this guy right here. This is all one variable. And then finally, the n in here is the sample size. Okay? That's how many people or whatever that you're looking at, that you're gathering data for. So these are the 3 variables. In a problem like this, if you see them mentioning something about standard deviation of sample means, or sometimes they switch around and say sample mean standard deviation, you're probably going to be using this formula. See if you're given 2 of these variables and you're asked to find the 3rd. So let's see, in this case, let's see what we're given. There is a population of students who have a mean of 237 friends. It's a mean of 237 friends. I don't really see anywhere in here for the mean, so I'm not sure if I'm going to use the number 237. Let's come back to that. With a standard deviation of 28 friends. Okay. Now we're talking. We're given a standard deviation of 28. Now this standard deviation, is this the population standard deviation or the sample? Well, later we're being asked for the standard deviation of the sample means. So this is the standard deviation of the population. It says so right here. The population with a standard deviation of 28. So this is the population standard deviation. So I can put that right here in this formula. 28 is the population standard deviation. Now, if you take 6 samples of this population, each with a sample size of 11. Now be careful, I've got that 6 and I've got that 11. Only one of those is the sample size, though. The sample size is the 11. It says so right here, sample size of 11. So that is going to go right here. Okay, for n. So that means I'm going to have the square root of 11, because that's a sample size. So the only thing I don't know is the standard deviation of the sample means. Okay, so I can just go ahead and solve for that now. Standard deviation of the sample means. And that's what we're supposed to find. Predict the standard deviation of the sample means. We're supposed to find this guy. So, now I can focus on that. How can I get this by itself? Well, I'm going to need to divide both sides by the square root of 11. So let's do that. So square root of 11, square root of 11. That way these will cancel each other out. So I've got, I'm not very good at this. Okay, so I've got the standard deviation of the sample means by itself. Let's put this in the calculator and see if we can get an exact answer, meaning with radicals instead of decimals, and we'll get a decimal answer as well. We'll get both right now. Let's see, 28 over radical 11. Let's see what we've got. Okay, so 28 over radical 11. That gives me 28 radical 11 over 11. So if they ask me for an exact answer, that's what I'll put. 28 radical 11 over 11. Now, how do I get the decimal answer? I'm supposed to get exact and a decimal. How do I get the decimal answer? Well, yeah, of course. We just hit the toggle key. So, toggle. So, 8.44. So that's how you find the standard deviation of the sample mean. Please memorize this formula. Practice it. Study it. You won't remember it if you don't study it over the weekend. Alright? Let's look at number 5. Last week, Mr. Finn went to Kroger. The mean cost of each item he bought was $4.75, with a standard deviation of 1.25. At the last minute, he remembered that he has a coupon for $1 off every item. If he uses the coupon, what will the mean cost of each item be? What will the standard deviation be? Okay. Alright, I think it might help if I make up some sample numbers to give you the idea. But the key is that the coupon will take $1 off every item. So for example, say if he bought one item, this is just some of the things he bought. Say he bought one item for $3.75 and another item for $4.75 and another item for $5.75. If he uses this coupon, alright, the coupon is going to give him $1 off every item. So, using this example, what would be the new price of these 3 items? Well, it's $1 off everything. So, this would become $2.75, $3.75, and $4.75. Okay? So, anyway, if we take $1 off every item, then the mean of everything is going to decrease by $1. See how these are all $1 cheaper? So if everything gets $1 cheaper, then the mean is going to decrease by exactly $1. So if the original mean was $4.75, sort of like this right here, the new mean is going to be $3.75, sort of like this right here. So we know for a fact that if everything goes down by $1, the mean will go down by $1. So the new mean will be $3.75. Okay? On the other hand, the standard deviation. Everything went down by $1. Does that mean the standard deviation is going to go down by $1? No, because standard deviation doesn't have anything to do with how big these numbers are or how small they are. What is standard deviation supposed to tell you? Right, it's supposed to tell you how far apart the values are or how close together they are. If I change all of the numbers by the exact same amount, in this case, they all got less by $1. Am I changing how spread out the values are? Or are they still the same distance from each other? Sure, hopefully you're seeing that if everything decreases by the same number, then we're just shifting the numbers down. But we're not changing how far apart the numbers are from each other. Okay, like in the example that I just made up, originally these items were $1 apart. These items were $1 apart. By taking $1 off of everything, guess what? These items are still $1 apart, and these two items are still $1 apart. So they didn't spread out, they didn't get closer together, so the standard deviation should stay the same. So the standard deviation was $1.25. So the new standard deviation should still be $1.25. Okay, let's look at number 6. Alright, this is number 6. Mr. Finn wanted to get a better idea of how many hours of sleep Roswell High School students get each night. So, this time he used 5 classes as a sample. Instead of just earlier, he just used 1 class. This time he used 5 classes as a sample. The sample size in each case was 21. They're mentioning sample size. That should be reminding you of something. And the standard deviation of the sample means what? That reminds me of something. They just said standard deviation of the sample means. What does that remind you of? Standard deviation of the sample means. Oh yeah. Whenever we do standard deviation of the sample means, that's when we need to use this formula that involves standard deviation of the sample means. This guy. Let me see if I can cut and paste this down here. Whoops, too much. Okay. Where are these numbers coming from? Okay, so we need to use this formula for a standard deviation of the sample mean. So here we go. What are we given though? Let me start over now that I know I'm definitely using this formula, man. He used each of his 5 classes as a sample. The sample size was 21. Sample size 21. That's what goes in this formula. This n represents a sample size. So this tells me that I have square root of 21. Okay, let's see. The standard deviation of the sample mean was 1.4. This time they just plain give us the standard deviation of the sample mean. Last time we had to find it. But this time we're given it, so that's going to go right here. This is the standard deviation of the sample mean, so 1.4 goes in this position. Now it says predict the standard deviation of the entire population. The entire population is the sigma. That's what this represents. So that's why we're going to go ahead and find the standard deviation of the population. So just put this in your calculator and that will give you the standard deviation of the population. 1.4 times the square root of 2. I think this is the best we can do in terms of having an exact answer. 1.4 times the square root of 21. Maybe you could turn 1.4 into a fraction. I'll do that just for fun. Okay, 1.4, toggle it. I said toggle it. That's 7 over 5. So if I really want to be awesome, I could write this as 7 radical 21 over 5. Okay, that's an exact answer. Exact. Now how about that decimal? 1.4 radical 21. Okay. 1.4 square root of 21. Okay, I get this. 6.41. I'm curious. No, that toggle wouldn't have worked. So 6.42. It just says decimal. It doesn't say how many. So I'll just say or 6.42. Okay, so please, again, you may have to use this formula. So if they mention anything about standard deviation of the sample mean, that's this guy. We're going to need the formula. If they mention sample size, that should be making you think we might use this formula, because this is pretty much the only formula where we used sample size. Okay, let's scroll down and see what else we have. Alright, number 7. Does the time of day affect your grades? Your teacher decides to compare the results of a recent test to see. Your teacher uses 10 students in first period and 7th period classes. So that data is shown here. These are the grades of the first period class, and these are the grades in the 7th period class. So we're supposed to find the mean, median, minimum, maximum, range, standard deviation, variance. Oh, better remember what the variance is, you guys. Stay tuned, pay attention, don't skip past that part. And we're going to have to tell which class had grades that are more consistent. Let's use the TI-30. Let's start with the first period class and type all that data in. So let's see, the first numbers are 10, 97, 88. So if we hit data, I would like to clear this out. I'm just going to reset the calculator. Second, 0, 2, memory cleared, back to data. So here's where you would just type in all the numbers. Okay, so I've typed the first period class into column 1 on this table. So you know how to do this part. most of the information that I need will be under the stat menu. So I'm going to hit second data, one variable statistics, just hit enter 3 times. So there's a lot of stuff in here. So that, there's my mean, 81.7. Let me just write down one thing at a time. So the mean is 87.1. Did I say 81.7? I meant 87.1. Okay, first period. The mean is 87. Whoa! What's that? Can I still write? 87.1. That is weird. I'm going with it, man. That was the mean. Better write that in too. Watch, it's going to go away in a second. 87.1. The median. Better check back. What was the median? The median is 90. The minimum is 67. It even says that on the calculator. And the maximum was 100. I mean, you can see it with your own eyes, but it does say the max and min right on the calculator. That means the range is going to be 33. Remember, how do I get the range? Yeah, I just get the range by doing the max minus min. So I did 100 minus 67. Now I'm supposed to find the standard deviation. Wait a minute, we have those two different kinds of standard deviation. 11.89, 11.28. How do I know which one of these I'm supposed to use? I remember that this item 3 is for the sample and item 4 is for the population, but this problem doesn't mention the word sample or population, so how do I know which one to use? Yeah, if it doesn't specifically say sample, we're going to go ahead and go with population. Okay? So let's go ahead and do this, the population standard deviation, which is just sigma. So we'll use the 11.28. 11.28. If it doesn't say sample, go with population. Now, what's this variance business? Well, guys, the variance is just the standard deviation squared. No, you will not find variance listed on your calculator anywhere. You have to take the standard deviation and square it. So if I want to find the variance, I'm going to do 11.28. I'm actually going to use a couple more decimals since I'm not done. 11.2823. Squared. And that gives me 127.29. That's the variance. Now, I want to show you a little trick here. Let me just clear this out. If I go back to my one variable statistics, real quick like, let's see, go down to, okay, see how the standard deviation is item 4? If I type the number 4 right now, bling, what it does is it prints the standard deviation on the screen where I can do calculations. So if I want to find the variance is just the standard deviation squared. So if I do it this way, remember when I was rounding, this avoids that. I get more accuracy. Wow, it even gave me a fraction. Okay, I am going to want to go ahead and get a decimal though, so I'm going to toggle that. So 127.29. So comparing that to what we put, we pretty much nailed it. But that's a good trick to have. You can actually use the standard deviation and make it print right from the list. Now, off camera, I'm just going to get all the information for period 7 right now. Alright, so here's the data from 7th period. Alright, so if you did this on your own, just double check your work and make sure everything's correct. Meanwhile, which class has grades that are more consistent? More consistent means lower standard deviation. Okay. More consistent means closer to being the same. So that would mean closer together. That's lower standard deviation. So let's see. 7th period had 11.05 as opposed to 1st period with 11.28. So for that reason, we can say 7th period is more consistent. Okay, because it had the lower standard deviation. Okay, moving on. Look at number 8. The Sony Corporation claims that the mean battery life of a PS Vita is 8 hours, 480 minutes, with a standard deviation of 45 minutes. So I guess we're doing minutes. You think that can't be right, so you get a sample of 10 PS Vitas to compare with the population. Okay, so we're comparing a sample with the population. Here's the data. Compute the mean and the standard deviation of the sample. Sample. Write a summary statement to compare the mean and the standard deviation of the population with the sample. Okay, so first we have to type all these numbers in our calculator, and this is the sample. Okay, these numbers represent the sample. The population are all the Sony PS Vitas that are ever sold. Okay, but these 10 calculators that we are testing represent the sample. That's why we're going to make sure to find the sample standard deviation. Okay, so take a minute and type those in your calculator. I'm going to do that off camera. Let me summarize the information that we have to compare. We're supposed to compare the population with the sample. Okay. Now, the population had a mean and it had a standard deviation. Okay, let's look back and see what it said. Let's see, the population claims, Sony Corporation claims that the mean battery life was 480 minutes. So population mean 480 minutes of battery life with a standard deviation of 45 minutes. So 45 minutes. Now, I just typed all this sample data into my calculator and I did a second stat to find the mean and the standard deviation. So the mean of the sample turned out to be 457. Okay, that's a little bit lower than the population. So my sample is not getting as good a battery life as Sony claimed. But the standard deviation, now they're clearly saying the word sample. So please, please make sure you're using the S when you do this, not the sigma. So this is 46.02. Okay, for the standard deviation. So the sample had a slightly higher standard deviation. So basically I'm just going to put all that into words. I'm going to write two sentences. Okay, let me color coordinate them. Alright, the red sentence I'm about to write pertains to the population. Okay, the red sentence is going to be all about the mean. Okay, so let's see, which one had a higher mean? The population You know what, I'm going to write the sentence off camera. Okay, so far I have the population has a higher mean battery life of 480 versus 457, I should probably say, minutes. Now, don't forget, you have to follow that up by saying what that means. Well, I guess I kind of included in here. I said higher mean battery life. So I'm covered. My next sentence, which I'm going to color in blue, is going to compare the two standard deviations. Make sure that somewhere in there you say the meaning. Don't just simply say which one has a higher standard deviation. You have to say something about battery life and what the standard deviation tells you about battery life. I'm going to write the sentence off camera, but you think about it. So the population has a lower standard deviation, 45 versus 46. This means that the population, whoa, left out a letter there. This means that the population batteries have battery life that is more consistent. Alright? Lower standard deviation means more consistent. I could have said it the other way, and I could have said that the sample had a higher standard deviation. Then I would have said this means that the sample battery life is more inconsistent, or it's more variable. Anyway, that's it for number 8. We're almost to the end. This has been a really long lesson. Number 9. The mean lifespan of a 100-watt bulb is 1,100 hours with a standard deviation of 100 hours. Draw and label the normal curve. And then we got all these percentages. Well, remember what the normal curve looks like. We draw this bell curve. In the middle of the bell curve, that's where we put the mean or the average. Every one of these marks going to the left and right is one standard deviation to the right and one standard deviation to the left from the mean. You need to memorize these percentages again. Get these back into your brain. Notice how many marks we do. We put one mark in the middle, we put one mark close to the end but not quite, and between those two marks we have just 2 additional marks. So please sort of think of it that way. Okay? Think of it as a middle. That should probably be more like red or something. Or I'll highlight, even better. Think of it as a middle, and then almost to the end, and then I put 2 marks in between that. I have a middle, almost to the end, and then I put 2 marks in between that. Think of it that way. So memorize these numbers: 34%, 13.5%, 2.35%, and 0.15%. Um, don't forget these either. If you look at the middle, like from the center, one standard deviation in both directions gives you a total of 68% of the data. If I go left and right two standard deviations and include all of this from here to here, that's going to be 95% of the data. If I go all the way three standard deviations to the left and to the right, three standard deviations will give me 99%, 0.7% of the data. So 68, 95, 99.7. You used to know them. Get them back in your head so you can use them for the test. You may have to study. Shocker. Okay, so here's my normal curve. Obviously, you'll have to draw it by hand, but do your best, man. Let's see. There's a mean lifespan of 100-watt bulb is 1,100. So that means right here in the middle, I'm going to have 1,100. Okay, that's the mean. Okay, so now let's see, going to the right, one standard deviation every time. Standard deviation is 100. So that means I'm going to add 100 going to the right. So this is going to be 1,200, 1,300, and 1,400. It's going to be the same deal going to the left. So this is just going to be plain 1,000. And this is going to be 900. And this is going to be 800. Okay? So, now we're ready to start answering these questions. Remember about the percentages. Okay? If we look back at the chart, we had 34%, 13.5%, 2.35%, and 0.15%. It will help if you fill those in. I would do that if I were you. Okay, you should draw them right on there. So. Okay, certainly for your packet, I should see these filled in. Okay, now we're ready to answer the question. Okay, draw and label the normal curve. Did it. What interval contains 68% of the data? Well, remember, 68% of the data, that was going to be, that's what we had if we just went one standard deviation in both directions. There's your 68% right there. So that means that's from 1,000 to 1,200. That's from here to here. Okay, so I will just write 1,000 to 1,200. You can just put it like that. What interval contains 95% of the data? Well, remember, 95% of the data went two standard deviations in both directions, like this. Okay, 95% went from here to here, two standard deviations. So that's 900 to 1,300. What interval contains 99.7% of the data? Well, that's the one that was 3 standard deviations in both directions. So all the way from here to here. Okay, 3 standard deviations. There's my 99.7%. So that's from 800 to 1,400. Okay, how long do the worst 16% of light bulbs last? The worst 16%. So we're going to be down on the left end. Let me erase some of this clutter here, so we can see better. Okay, the worst 16%. It's just a matter of how many of these bottom intervals it takes to make 16%. It turns out that if I add up the bottom 3, that's going to make 16%. So the worst 16%, how long do they last? Well, it goes, this bottom 3 zones start at 1,000. And see how this is open-ended? That's because this end of the graph goes forever. It doesn't stop. It goes forever to the left. So we're going to say, how long do they last? Less than 1,000 hours. Okay, because that's where that starts. How long do the best 2.5% of light bulbs last? Well, the best 2.5%, that's this the last 2 zones over here on the right. This starts at 1,300, right? But then, because it includes this last zone, it goes forever to the right. So the mistake a lot of kids made on the last, when we actually learned this back in the day, they put an end on it. They wanted to say from 1,300 to 1,400. That only got 1 zone. Or maybe they tried to say 1,300 to 1,500. But this zone does not end at the next standard deviation. So you can't do that. So instead, you have to say longer than or more than 1,300 hours. Longer than 1,300, because that's where this 2.5% begins, right there. Okay, what percent of bulbs last at most 1,000 hours? Well, that's a tricky way to say it, but at most 1,000 hours actually means 1,000 or less. Okay, and we already have that marked, 1,000 or less, because of a previous problem, because of problem E. That's 16%. We already sort of figured that out. So what percent? 16%. You see 1,000 or less. If I add up these 3 percentages, that's 16. What percent of bulbs last at least 1,400 hours? Okay, please understand, at least 1,400 means 1,400 or more. Okay, that's what it means when you say at least. So we have to start with 1,400 and go more. How many zones is that if we start at 1,400 and go more? That's just the one zone, the little zone. What percentage was that? 0.15%. Okay, at least 1,400 hours. Now, what percentage of light bulbs survive between 900 and 1,200 hours? Okay, let's see what we're talking about. Between 900 and 1,200. Okay, so see these percentages, 34, 34, 13.5. Just add those up and that'll tell you what it is. Okay, we're just doing 13.5 plus 34 plus 34. Okay, so that should be giving you 81.5%. Is that the end? My goodness, that's got to be some kind of a record. This is the longest lesson ever. I don't think it would even fit in a class period. Anyway, that's the end.